All right, so now let's talk about how to use the unit circle to find exact values for our inverse cosine function. And it's the exact same process as we used for sine inverse. All right, so remember, all of our inverse trig functions give us angles. So an angle is the answer for an inverse trig function question. All right, so what we're going to do is rewrite our angle in terms of its inverse, so cosine theta. And we want to make sure that our angle is between 0 and pi because that is how we restricted the domain. Right? We only want angles between 0 and pi. Okay, and then it says use the exact values on the unit circle to find the correct value of theta in that interval. So the thing we need to remember is that the range, so our answer of cosine inverse, or arc cosine, is 0 to pi. So let's talk about what quadrants that's in. All right, so 0 to pi. That tells us we need to be looking in quadrant 1 and quadrant 2, and if it's not in those two quadrants, it's not the answer. So Q1 and Q2 are the places we need to look. Okay? All right, so let's find the exact value of cosine inverse of root 3 over 2. All right, remember, first things first. Our answer is an angle. We're looking for theta. Theta is defined by cosine inverse of root 3 over 2. Okay, and again, we're not used to looking at things like that, so we're going to rewrite it into the form that we're used to looking at. Cosine theta is root 3 over 2. So we need to find all of the places on our unit circle where cosine of theta is root 3 over 2. All right, so cosine, here is cosine, root 3 over 2, that happens at pi over 6. It also happens, where's root 3 over 2? It also, cosine, sorry, I'm looking at the wrong place. Also happens over here, right, at 11 pi over 6. We saw that 11 pi over 6 was in the fourth quadrant. That is not what we're looking for. So our answer is pi over 6. It's in the first quadrant. It's between 0 and pi, so that is our answer. Okay. All right, now let's look at cosine inverse of negative root 2 over 2. Okay, so that means our angle is cosine inverse of negative root 2 over 2. So we need to figure out cosine theta equals negative root 2 over 2 for what angle? Theta. Cosine negative root 2 over 2, well I'm looking at the wrong thing, I'm looking at sine. Here, negative root 2 over 2, that happens at 3 pi over 4. Also, it looks like it happens at 5 pi over 4. Only one of those is in quadrant 1 or 2. So our answer is 3 pi over 4. All right, so you don't have to go through this whole process all the time. I just wanted to show you guys where all of this is coming from. So finally, cosine inverse of 1/2, cosine inverse 1/2. So we want to find the angle such that cosine theta is 1/2. So let's find all of the places where cosine theta is 1/2. That would be pi over 3. We can already expect that's going to be our answer. Also, 5 pi over 3. Only one of those is in the appropriate quadrant. So the answer is pi over 3. Okay? All right, let's move on to tangent. So tangent's one we haven't graphed before, but I'll graph it for you and show you that it looks a little interesting. Okay, so let's talk about tangent inverse. All right, so difficult to graph. We're going to have to divide sine over cosine to get our tangent values. So I'm going to kind of do it for us. So I'm going to do the usual number line, pi over 2, pi 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and so on. Maybe I'll put a 1 and a negative 1. Okay, so if you remember, our tangent function, y equals tangent of x. Our tangent function is not defined everywhere. So remember, tangent is sine over cosine. So everywhere that cosine is 0 is where tangent is going to be undefined. So let's start there. Everywhere where cosine is 0 at like pi over 2, 3 pi over 2, so odd multiples of pi over 2, our tangent is undefined, and it actually has asymptotes there. So I'm going to put asymptotes at my odd multiples of pi over 2. So this is where our graph will not be defined, there. And in fact, what happens is, as we approach our asymptotes, our tangent goes up forever, and on the other side it goes down forever. So it looks like that on each side. And I know that tangent is 0 everywhere that sine is 0. That's why it's 0 at 0, pi, and negative pi. So this is our graph of tangent. It looks a little strange. Okay, does this pass the horizontal line test? No, it does not. Clearly not. So does not pass horizontal line test. So actually, none of our trig functions pass the horizontal line test. Sorry, there was a bug in here. So what we have to do is restrict our domain. So we want to choose something that has the 0, and we want to choose a place where we will pass the horizontal line test. And in fact, we're going to use negative pi over 2 to pi over 2, but notice tangent is not defined there. So we're actually going to use open intervals. Okay, so on our restricted domain of tangent, we're going from negative pi over 2 to positive pi over 2. So that is going to be the range for our inverse. And so notice the range of our tangent goes from positive infinity to negative infinity, or the reverse. So that's going to be the domain. So the domain of our tangent inverse is negative infinity to positive infinity. So this one is a little different than the others, but that's okay. We can still work through this. All right, so let's talk about how to solve these problems. Same process you've seen before. We're going to say that inverse tangent gives us an angle. We want to make sure that angle is between negative pi over 2 and positive pi over 2, not including, and we're going to choose the correct places on the unit circle. All right, so I'm going to write down the range. So our answers for tangent inverse is negative pi over 2 to pi over 2. All right, and we know exactly what quadrants that happens. Negative pi over 2 is down here. Pi over 2 is up here. So we're talking about quadrants 1 and 4 is where our angles will be located. And so notice our unit circle does not tell us our tangent values. So we're going to have to do a lot of thinking for this one. So we also need to remember that tangent theta is sine theta divided by cosine theta. So we need to keep that in our mind when we're trying to figure out these problems. All right, so let's do some examples.